Hi Year 11, it's a little video just to go through the idea of correlation and finding lines of best fit. Now, the idea of a scatter graph, I think you probably already know and you probably find quite easy. So this is Neil owns an ice cream van. This scatter diagram shows information on the temperature and number of ice creams he sold each afternoon from the 1st of August to the 7th of August. So first question, why are there 7 crosses on the diagram? Well, hopefully that's obvious. Each cross represents the data you've collected for those 2 pieces of information per day. So, there's reason why there's 7 crosses because we've done it for 7 days. On the 8th of August, it was 21 degrees in the afternoon and he sold 40 ice creams. Plot this information. So 2140, it's maybe like somewhere like that. Make sure you're precise. Okay, so we've got an 8th piece of data into this scatter graph. Describe the correlation between the temperature and the number of ice creams. Now, clearly this is what we would call a strong positive correlation, which really means as the temperature increases, we would expect the number of ice creams sold to increase. Okay? Now, draw a line of best fit. Now, what you can do sometimes you'll be asked to draw in a line of best fit using a ruler, and if that is the case, you just do the best you can. Okay, you have a data that roughly shows the trend of the data, and you want about half the points above the line, about half the points below the line. That's probably not the best effort from me there. Let's just try and improve that. Maybe more like something like this might be a bit better. Who knows? I mean, fact is, it's not an exact science. Okay. However, there is a way of using a calculator to find out exactly what the best line of best fit is. Okay. Now I'm going to show you that in a separate video. So please make sure you watch that as well. So we've drawn the line of best fit. It says on the 9th of August, it was 28 degrees C. Estimate the number of ice creams sold that afternoon. So we use our line of best fit. We go to 28, which is 30 is here, 28's here. So we use a ruler. I can't use a ruler. You will use a ruler. Best estimate, I think, is that we're going to sell about 63 ice creams. About 63 ice creams. So we can use this kind of maths to make predictions. Okay, obviously we're not necessarily going to get it right, but we would hope that my prediction is somewhat accurate. Okay, on 28th of September it was 10 degrees. Does it make sense to use a line of best fit to estimate how many ice creams are sold? Well, hopefully you can see not. Okay. Fact is, if I carried on my line, that would suggest I'm selling a negative number of ice creams, which is not possible. You can't sell a negative number of ice creams. So your line of best fit is only accurate between the data that you've recorded. Okay, so you wouldn't really want to use your line of best fit outside of these values. Okay, either of the number of ice creams sold or the temperature sold. That is an example of what we call extrapolation. You are looking outside of the range of the data that you collected. So your result, your prediction is not necessarily wrong, but it's not as reliable. We would have to question whether it's really reliable. Okay, so the answer is no. It wouldn't make sense for you to do that. So we've got all types of relationships we can have. We've got strong positive. This is definitely a strong positive correlation. Okay, this would be a weak positive correlation. You can see that the general trend is as one variable increases, so does the other. But any predictions you make are inherently more unreliable because each of these points are further away from that line than in the really, really strong one where all of those points were really, really close to the line. Okay. Outliers. how many outliers? Well, I just think there's one. Oh, actually two. There's an outlier here and here. Two outliers. Points that just don't seem to make sense with the rest of the data. Okay, so outliers don't necessarily mean that data is wrong. It could be that the data is wrong, or it could be that somebody, for example, if we were looking at exam scores and we had an outlier, it could mean that somebody collected the data incorrectly. It could mean that person cheated, or it could mean that person was sick that day. We don't know. We'd have to investigate. So outliers don't imply that piece of data is wrong. It implies that you should investigate what's happened with, why is this so out of step with this? What's the reason? Okay, there might be a reason for it. What do we got here? We got strong negative correlation. Okay, quite close to that line. But this time, as one variable increases, the other variable decreases. Okay, so as I increase my values of x, then you can see that my y value is decreasing the more I increase x. Okay, have a little go at this question. Stop your video and have a go. Okay, here's the answer. Why didn't that reveal? Oh well, whatever. Okay, line of best fit would be something like this, and you'd use that to do your predictions. Okay, obviously their prediction is 42. If your answer is slightly different, that's okay. There'll be a range of acceptable answers. Okay, you don't have to get it perfect because your line of best fit is not perfect. Okay, again, have a go at this one. Okay, here's the answers. Don't seem to be able to reveal the graph. So the question down here, another student missed the test and took it later. Could you use the student score and a line of best fit to make a confident estimate of the amount of time they spent watching TV? Well, no, because this correlation is weak, then any predictions you make are less reliable. So the weaker the correlation, the less confidence you can have in any predictions that you make. Okay, another one, have a go. Okay, line of best fit, something like that. Ignore any outliers. Okay, and there are your answers. Right, now this scatter diagram shows information on the number of jellyfish stings reported by tourists and the number of umbrellas sold each month at a beach on a tropical island last year. Callum says the more umbrellas people buy, the fewer jellyfish stings there are. So buying umbrellas prevents jellyfish stings. What is wrong with Callum's first sentence? And do you think his second sentence is a reasonable conclusion to draw from the scatter graph? The answer is no. That's not a reasonable conclusion. Buying an umbrella does not save you from a jellyfish sting. What happens is, if it rains, you're less likely to go in the sea, and you're more likely to buy an umbrella. Okay? So the essence of this is that correlation does not mean causation. I can't say, like for example, this is a very true thing. If you increase ice cream sales, then the murder rate goes up. That's actually true. But that's not because ice cream makes you want to kill people. Eating ice cream does not cause you to kill. The reason is because they're both linked to temperature. As you increase the temperature, you increase the number of ice cream sold, but you also, people tend to be more ratty in hot temperatures and they commit more murders. So it would appear that there's a link between the two, but there isn't really. They're both linked to a third variable. Okay, so no, doesn't really make any sense. Right, a little exam style question here. This scatter diagram shows information on the heights and masses of giraffes in a national park. What type of correlation? That should be easy. Use a graph to estimate the mass of a giraffe that is 4.1 meters tall. You'd put in your line of best fit, go to 4.1 and read off what you think the answer is going to be. Okay, let's leave that. Right, now, in the next video, you're going to see how we can use a calculator to find what is the best line of best fit. So actually, in fact, let's go back to the one where I was having doubts. Just go back to this one. I wasn't entirely sure where my line of best fit should be. I was thinking, okay, should it be like this? Or should it be more like this? Right, who knows what that line of best fit is? So what I'm going to do in the next video is show you how to find out exactly what the equation of that line of